So today we are gonna prove two most important theorems. Okay, so far. So the first theorem is called measure of an increasing union. Okay, so standard setting of the theorem is let X as mu is a measure space and we have an increasing sequence of sets in S, then measure of union of k is equal to 1 up to infinity ek is actually limit k approaches to infinity measure of ek. So proof, we are gonna prove this thing. So suppose if measure of ek is infinity for some k, then the equation holds. So then there is nothing to prove. Why? Because if measure of ek is infinity for some k, then we know that ek is contained in union of the ek's, and if the one of the ek measure is infinity, this means the union of those sets will have measure infinity. So infinity is equal to infinity, then there is nothing to prove. So we assume that okay, so we assume measure of ek is finite for all k. Now whenever we wanna use this measure definition to prove something, the first thing comes into mind that we are gonna always come up with the disjoint sets, then we can use the second property. So to do that, what we can do? So first thing, let we say that E naught is empty set, and also to see that, we can see that suppose if this is my E1 and this is my E2 and this is my E3. Okay, so now we can see, what do you think about this area? So this is nothing but this is E2 difference E1, and what we think about this area, so this is nothing but this is E3 difference E2, right? And if we keep going, then we will see that okay, we will have disjoint sequence of disjoint set, and the union will be actually ek. So from here we can see that, so we have let E naught is equal to phi, and then we have another set which is so what can I do? I can have E2 difference E1 and then E3 difference E2 up to so on. So keep going, and now we can see that the union of k is equal to up to infinity ek is nothing but this is union of, we are gonna use different indices, j is equal to up to infinity ej difference ej minus 1. Now we can just go ahead and use the second property of measure. So we saw that measure of union of k is equal to 1 up to infinity, this ek is nothing but this is measure of union of j is equal to 1 up to infinity ej difference ej minus 1. Now since they are all disjoint, so by second property, this is j1 infinity measure of ej difference ej minus 1. Now this can be written as limit k approaches to infinity, sum of j is equal to 1 up to k, and this is measure of ej difference ej minus 1. Now this is k approaches to infinity. What is this? So this is measure of E1 minus measure of E0 plus measure of E2 minus measure of E1 plus up to so on. At the end we will be able to see that plus measure of ek minus measure of ek minus 1, and the term will be cancelled out. So what we have, so this is limit k approaches to infinity, measure of ek minus measure of e naught. But since measure of e naught is measure of empty, because since e naught is empty, so measure of empty set is 0, and what we have is this thing. So done. This proof was very simple. Okay, now we're gonna use this proposition to prove another proposition, that if we have a decreasing sequence of sets. So second proposition is that if we have, so the same standard is we have in the same kind of setup, but we have now e1 is contained in e2 is contained in e3 up to so on, is a sequence, decreasing sequence, is a decreasing sequence of sets in S. Then measure of intersection k is equal to 1 up to infinity ek is actually limit k approaches to infinity measure of ek, provided that measure of e1 is finite. You are gonna see that in a minute. But proofs, we want to use the previous result. Previous result says that if we have an increasing sequence of sets, then so we are gonna come up with increasing sequence of sets. Okay, so we say that let f1 is even difference even, and f2 is even difference e2, and so on, and f3 is even difference e3 up to so on. Then clearly f1 is contained in f2 is contained in f3 is contained in f4 up to so on. To see that how, so like it is very obvious. So suppose if this is e3 and this is my e2, and suppose if this is my e1, now what can we say about this part? So this part is nothing but this part is e1 difference e2, and what we can say about this part? Okay, so this part is nothing but e2 difference e3, no, e1 so this part, whole part is nothing, like this whole part is nothing but this is e1 difference e3. Now we can easily see that this e1 difference e2 part is contains in e2 difference e3. So that's why f1 is contained in f2 is contained in f3. Like that's all very obvious. Okay, I hope you understand this point. Now, and also the union, okay, also, so now we can see that this is like very obvious. So now since we have an increasing sequence of set, then the previous theorem says that measure of union of k is equal to 1 up to infinity fk is nothing but this is limit k approaches to infinity measure of fk. So fk by definition this will be nothing but this is e1. What is fk? Difference ek. Okay, so now if this is the thing, then what we can say? So now since measure of union of k is equal to 1 up to infinity fk is nothing but this is e1 difference ek, and then this is limit k approaches to infinity. What is measure of e1 difference ek? Now what De Morgan law says, k1 infinity e1 difference ek, this is e1 intersection, okay, k is equal to e1 difference, sorry. So this is like De Morgan law. So De Morgan law says that even difference intersection of k is equal to 1 up to infinity ek. Okay, this is De Morgan law. De Morgan's law. Okay, so then we can replace that measure of, so union of ek, even difference ek is nothing but this is e1 intersection of k1 infinity ek, and on the other hand this is, and measure of e1, so this is measure of e1 minus measure of ek. But now what is this? This is measure of e1 minus measure of intersection of k1 infinity ek, and so this is measure of e1 minus limit k approaches to infinity measure of ek. So that was the condition, that we put a condition that okay, the measure of e1 is finite. Why? Because if it is infinite you cannot cancel. Now you can cancel and you can see that this is measure of intersection of k1 infinity ek is actually limit k approaches to infinity measure of ek, and we are done. So see, we just use the previous result, nothing at all. Okay, so thank you.